So dealing with our fertilizer activity, farm product manufacturer wants to determine if the yield of crops is different when the soil is treated with two different types of fertilizers. So we have 16 plots of land that I've numbered 1 to 16 beside a river that has several trees along its bank. These 16 plots are planted with the same type of seed but are fertilized differently. At the end of the growing season, the mean yield from the sample plots is compared. So the mean yield means the average. That's our response variable, the mean yield, how much is harvested from each of the sample plots. There are 16 plots of land. That's our experimental units. The factors are 1, the fertilizer, with 1 level. They're each getting the same amount. How many treatments are there? There are 2 treatments. There's fertilizer A and fertilizer B. So those are 2 different treatments, all 1 level, 1 fertilizer, 1 factor. That's the fertilizer. Okay, so we looked at the various extraneous variables. We talked about the weather, whether it's the wind, the rain, the storms, hot weather, soil content, uh, the content of the soil, the proximity to the river, the location of the trees, various animal pests, insect pests, and weeds, various things that could affect the mean yield from each of the plots. Okay, and which of those can we control? We can try to control each of these 3. We can't really control the weather, the river, or the trees. Soil content, maybe we can add something else, but that may be another fertilizer. And the question is asked, do we have replication? Is this an experiment? It is an experiment because, yes, we have half the plots are going to get fertilizer A, half of these are going to get fertilizer A, and the other half are going to get fertilizer B. That's where we have to determine because we want it completely randomized. So we numbered the plots. Whoops, sorry, got too much stuff on the screen there. So we numbered the plots 1 to 16, and then using a random number generator to choose 8 plots to get fertilizer A, and the rest get fertilizer B. So I don't have a calculator in hand, but I'm going to use the one on the screen. And to do that, you go stat. I'm sorry, no, you don't. I always start with stat. You go math, go over to probability, and choose number 8. Okay, your upper level is 1, lower level, excuse me, that's just the opposite. Lower level is 1, upper level is 2, and N is 8 because you want 8 different plots picked. So I'm going to go math, go over to probability, pick number 8. Again, the lower is 1, the upper is 16. Did I say it was 8? I said 2 for some odd reason. This is going to be 16 because we have 16 plots of land. I'll catch up one of these days, and N is 8. I know that part. All right, and then we paste that onto our screen. And the numbers I got when I did that, it tells me 16, 15, doesn't matter the order, 3, 9, 7, 12, 1, and 6. 1, 2, 3, 4, 5, 6, 7, 8. So 8 different plots of land are going to get A. You could have assigned them B if you wanted to. It doesn't matter. It's supposed to be an A. See, I get myself talking into these things. A, 9 is A, 7 is A, 12 is A, 1 is A, and then last but not least is 6 is A. So I went 16, 15, 3, 9, 7, 12, 1, and 6 got A. So all the rest of them then get B's. And it doesn't matter where they fall. This is randomization. That's what we want, random assignment. We randomly assign fertilizer A or B to each of these. Again, that's an A. Now, A, B, A, B, B, A, B, B. That may not be good. A, A. But here we have the equal. This is better than the one I did in class. This could work. This could work by random assignment. So we look at it and say, we have these B's here. Maybe they'll be affected more by the river than this B here or these B's over here or these A's that are here, 1A. And we want a little bit more balanced. So what we do, what we do is what is called a random block assignment. a random block assignment. So a randomized block assignment is when the experimental units are first divided into homogeneous groups. Then the experimental units are randomly assigned to treatments. So we're going to divide them into groups. We're going to do 4 columns here. And we discussed in class the proximity to the trees or the river, whatever you wanted to call it, river and trees, trees and river. And so by blocking according to the proximity to the river, trees, whatever you wanted to call it, proximity, the distance to the trees, we will have 4 vertical plots per block and randomly assign the fertilizer using a random number generator, a random number generator with 2 of the 4 plots picked and assigned fertilizer A, the other 2 plots get fertilizer B. So then I go back to my random number generator and I go again to math, go over to probability, pick number 8. Again, my lower number is 1, upper number now is 4, and n equals 2 because I want 2 of the 4, and I'm going to assign them fertilizer A, and then the other 2 I will assign fertilizer B. Okay, and so the first pair on this first column, I get 4 and 1. So this gets A, and this gets A. I may have to use a different color on these, see if it doesn't show up a little bit better. And so these 2 get B. That shows up better, doesn't it? I can do A and B like that. And then I do it again, and I get 4 and 1 again. So again, this is A, and this is B. Then I do it again. I get 2 and 1. So A and A, B and B. And then I do it one last time, and I get 4 and 1 again. That's too funny. So A, B, B, A. But it's randomized. It's randomized, picking using the random number generator, lower number 1, upper number 4, picking 2 numbers from 1 to 4, and then I get this look. Okay? So this row gets all A. This row gets all B. And these 2 rows get a mixture of A or B. And then again, once we run after so many weeks, the crop is harvested and we determine which has the highest average mean yield. But we decide, hey, what if we divide these into pairs where we try to determine, we match them up called into homogeneous pairs, that these 2 are close alike, these 2 because their proximity to the trees and the river, and these two, and these two, and these two, and these two. Now I know in class I showed a different one, but this one still works. Okay, so this is a matched pairs is a special type of blocking where the experimental units are placed into homogeneous pairs. Then one unit is randomly assigned to a treatment, and the other unit gets the other treatment. So I flip a coin, and all right, so assigning them into pairs, plot pairs is what I'm going to call them. I will use a random number generator to pick which plot gets fertilizer A, gets fertilizer A, and the other to get fertilizer B. We can use a random number generator. We can flip a coin, assign heads to A and tails to B, or whatever we want to do. On this one, if I'm using the random number generator, the lower number is 1, upper number is 2, and n equals 1. And so I'll pull that out. And I put my numbers in. And so for the first pair is 1. So this is A and this is B. For my next pair, I get a 2. So this is B and this is A. And then for my next pair, I get a 2 again. So this is A, whoops, this is B and this is A. Sorry, I got carried away there. For my next pair, I get 2 again. So this is A and this is B. And then I get a 1. So this is A and this is B. And then this is A and this is B. This is A and this is B. You completely randomized that one, our pairs. And then this one was A and this was B. Okay. AB, 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 BA, 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 AB. Total mixture there. And then we go back again and check the mean yield and see which gets the most. I hope that helps.